go through this one. Sine of C. So angle C, sine is opposite over hypotenuse. So what is sine of C? 3 over 5, opposite over hypotenuse. For cos of C, adjacent over hypotenuse, 4 over 5. And tan would be opposite over adjacent, 3 over 4. Good. And angle C, we can use inverse of any one of these. It's up to you. So if we did inverse sine of 3 over 5, it would be 37. And does that make sense? Yeah, because our other angle was 53 degrees. We know that these two will always add, the two acute angles will always add to what? 90 degrees, because the other 90 is already taken. And we know that the three angles add to 180. Okay, so let's look at an example. All right. Okay, it says solve the triangle. Given angle B is 90 degrees, so we're going to add in our little box. AB is 9 centimeters. And BC is 17 centimeters. Now, a little note, if they said solve the triangle and they didn't specifically tell you what to find, that means you have to find everything unknown, all unknown angles and sides. But this one's specifically saying find angle C. Okay, so we can do this. Where do we start? So we have to figure out which ratio to use. How do you get to knowing which ratio we use? Okay, which sides are given? So this side, 9 is opposite, and 17 is adjacent. We have the legs. So that would be tan, TOA. All right, SOHCAHTOA. Oh, so we want tan. And it's good to write the formula out first. You're less likely OPP over ADG. That's what they said on the song. Okay, you're less likely to make a mistake writing the formula out properly. Okay, so tan, let's put actually which angle we're solving for. So you could leave it as theta, or we could also write what? C, tan C, because we're looking for angle C, equals 9 opposite over adjacent, 9 over 17. And to move the tan to the other side, what do we have to use? Inverse tan. We're looking for an angle, we use inverse. And what do we get? 20 degrees? 28. Thank you, sorry. 28 degrees. Man, I wish it was 28 degrees today. No? Dave, don't go yet? Okay, so if you're done writing down that question, I'd like you to draw number 2. Draw number 2 that you have there. So they give you the word triangle. Is it 3? Oh yeah, sorry, number 3. That's the one I meant. This one? Yeah. Oh, is that what it looks like? No. That one, a 20-meter tower, right? Yeah. A 20-meter tower is supported by a 40-meter long guy wire. Attach the top of the tower. Find the angle of inclination the guy wire makes with the ground correct to 1 decimal place. Okay. So we have a tower supported by what? We're always going to be drawing a right triangle, or eventually we should get some right triangles. Where does the 20-meter go? The side of the vertical? Yeah. Where does the 40 meters go? The hypotenuse. That's where the wire is. And what are we looking for? Inclination. So that would be top or bottom? Bottom, right? From horizontal up is the angle of inclination. If I was looking for angle of depression, then that would be here. Okay, that would be the angle of depression. You could just basically invert your triangle or solve for the top one and go 90 minus whatever you get for the top angle. Okay, but we're solving for elevation. So we got to label our sides. That's our first step. So what do we have here? What sides do we know? Opposite and hypotenuse. Which ratio are we going to use? Okay, sine, yeah. O and H is sine. So sine of our angle is opposite over hypotenuse. Yeah, thank you. Okay, so it's going to be what divided by what? 20 divided by 4. Put out your hand. I need to slap you. Just kidding. In the olden days, that's what they would have done. Count yourself lucky, Carson. Any more out there? What happened to the back of my classroom? Oh, don't make me pause this video. Okay. So 20 over 40. Why do we know for a fact it can't be 40 over 20? Hypotenuse, the largest side, is always on the bottom. Okay, we want our angle by itself. How do we get the angle by itself? Inverse sine. To move it to the other side, you use inverse, which is 30 degrees. And there you go. There's our, and it's a word problem, so what should you write? Therefore, thank you. To one decimal, good reading. Okay, so the angle of elevation. Hey guys. Is 30.0 degrees. All right, can you draw the next one? Give it a shot. This is your number 4. From a 20-meter high fire tower, a fire spotted an angle of depression of 2 degrees. The fire from the tower. How far is the fire from the tower? From horizontal down is depression. Horizontal down. Okay. 1 second. Oh, here you go. We're good. Okay, so I have a tower, a fire tower that we're in. It's really high. It's insanely high, actually. 20 meters, little guy in there watching for fires. Okay. 1 second. So if you see, and you see a fire, you know a fire, it's going to be a huge, this is not drawn to scale. None of ours will. Why? Because 2 degrees is a really tiny angle. So we have a fire. But that does not look like a fire. On fire. Okay, so a fire spotted. So here's my recommendation to you is you draw your triangle inverted. Because angle of depression is from the horizontal down. So if we know we're going, here's the line of sight to the fire. The angle of depression is from the horizontal down. So that means we want to draw our triangle like this. Because they give us this, 2 degrees. Well, it does, because if that's 20, the vertical over here is also 20. Okay? You could also, if you know your angle of depression, you could also just go 90 minus that and put this angle here as 88.
Which is what I did.
Yeah, and you can totally do that as well. So if they give you an angle of depression, you could also instead go, okay, well then 90 minus that is 88. And do you have a question or you got it? Okay. All right, so I'm going to use this red triangle. And what are we looking for? How far is the fire? This is a tough one. It would actually be from, I should have said the base of the tower. From the base of the tower. Okay, so which one will you actually be looking for then? Yeah, this side here, the horizontal here. That's what we're looking for. We were looking how far away is it from the base of the tower. That's what I should have said in there. Okay, so if I use this triangle up above with the 2 degrees, what do I have? Let's label our triangle. What do we know? Opposite is the 20. We know the opposite, and we're looking for the adjacent. Because I should have wrote from the base of the tower, how far away is the fire?
Well, it's the same answer anyway.
Okay? Yeah, it's such a small angle. Does that make sense? I just added this wording in there, Carson. From the base of the tower, how far is the fire? Yeah, I added that. Okay, so which ratio has O and A? No. So, ka, toa. Tan. Sorry. Okay, so tan of, Joel, Hayden, listen up. Tan of Hayden, no, tan of what? 2 degrees equals 20 over x. Okay, if x is on the bottom, then what? These two switch. So x equals 20 over tan 2. We're going to have division. Okay, it's going to be really large because this is a very tiny angle. So 20 divided by tan 2 gives you to the nearest what? Meter is? 573 meters. Let me see. I just want to make one more note. I'll let you get started right away. When a problem says solve a triangle, okay, if it just says solve, so we can omit this one, because I think you'll be fine. But what does it mean to solve a triangle? So find all unknown measurements. So all unknown angles and sides. Okay, everything that's unknown, that's what it means to solve. And you will have like a question like that on your written response. So I'll ask you to solve a triangle. You have to find all unknown angles and sides. Okay? All right, so let's, your homework, when it says 3 to 6 odd, can someone tell me what that actually means? 3AC, 4AC, 5AC, 6AC. And then 7, 8, 9, 10, 11, 12. Okay? So you have lots of time. It's a Thursday, so it works out well.